right?
Yeah.
All right. Okay, so we have a triangle ABC with circumcenter O. Let me move that triangle a little. And then we draw a point. I'm going to have to think how to do this. So that ABD is equal to DCA. So it's kind of like, so yeah, ABD is, so we want to take this angle and kind of copy it here. Yeah, how should I do that? I could, so I guess I could draw the circumcircle of BAD. Yeah, there's a couple different ways I could do this. So first, yeah, I don't know if this is the best way to do it, but I have one way to do it. First, let me draw the angle bisector. And then I'll reflect B and D over it.
There's an easier way, actually.
Oh, there is an easy way? What's the easy way?
We can draw the circle of ABC and then a circle centered at A.
Oh, you mean just to get D prime and B prime?
If we draw the circle centered at A and let it intersect the circle.
Sorry. So a circle centered at
any circle.
Any circle. Okay. All right.
Yeah, name these points.
Of intersection.
Yeah.
Okay.
And now intersect CF and BG.
Michael.
Mm-hmm.
So I thought that so you need to draw the point D, right?
Yeah. So yeah, there's more than one possibility for the point D, but
so A, B, C, D is cyclic. So you only need to choose a point D on the circumcircle of ABC. Oh no. Oh yeah. That's correct.
Yeah, Serdar has a way. I think Serdar's way should work. So yeah. I'm gonna rename this point right here. Oh yeah, I should delete this point actually, right?
Yeah. Hold on. Just choose a point on the circumcircle of ABC.
Sorry. Okay, so let me just delete point D. And this point right here is the point D that we want. So because angle ABG is equal to angle AFG is AGF is ACD. I like that. All right, so now I'm going to hide the circle. Yeah, that was creative. And M is the midpoint of AD. So I don't want to make it look like AD is perpendicular to BC. Let me see if I can. Yeah, I might want to move point E around a little bit and then hide it. Maybe that's good. Let's see. I kind of like that. So I'll hide point E. I'll rename that M. And suppose that BM and CM intersect the circle at E and F. Oh, I should actually really hide F and G too.
Yeah.
Yeah, in this contest, they actually give you pictures for all the problems, even though you probably don't need it. But yeah. So all right, so this is E. And this point is F. Let P be a point on E. Okay, so we draw the tangent to the circle at A, and we let it intersect EF at point P. And then we want to show that APMO is cyclic. So I'm going to want to draw O, of course. So this is P. And O is the center. I think the circle is called C. I'm not 100%. There we go. So APMO. That's like the Asian Pacific Math Olympiad. Interesting. Let me read the chat for a second. Oh, sorry, Hakan. I missed your chat on how to do it. Okay. Yeah. Oh, that's all right. So how do we show something cyclic? Power of a point, angle chase. What are all the different ways? Angle chase seems maybe a little tricky. Power of a point.
Actually, inversion seems nice
Inversion.
because there are weird angles.
All right. So should I invert about A?
Yeah.
Should it just be an arbitrary radius?
Yeah, arbitrary.
Maybe I could use this circle, right?
Yeah. Because the advantage is AD will be internal bisector of B prime, D prime, C prime.
Okay. So yeah, you're basically finding a way to use this angle condition.
Yeah.
Actually, so the circumcircles of ADB and ADC are the same size. I don't know if that does anything. Okay, so if I invert about this circle, let's see. I don't think B prime lies on BC, right? No, it's just like a coincidence. Let me unhide point G just so that, or I'm sorry, at this point, just so I can make it. Yeah, maybe like that. Okay, so so what was it that you were saying? So what's the angle bisector?
D prime A is the angle bisector of B prime, D prime, C prime.
Okay, because this angle is equal to that angle and this angle is equal to that angle. That makes sense. All right, so so to say that APMO is cyclic, that means M prime, O prime, and P prime are collinear, right? Let me draw M prime. Oops. So M prime is going to be like twice AB prime, I think, right? So M prime is just far away. Let's see. There's M prime. All right. Let me shrink it a little bit. So now D prime is the midpoint of a M prime. And we have an angle bisector here. So I'm going to show it. Yeah, maybe like, because we can choose what we want the radius of this circle to be. So like we could make it pass through D or O, right? Oh no, because D, well, I guess we could choose the radius of inversion. So it doesn't have to be this circle.
Well, we didn't think about O.
Yeah, we'd have to think about where E and F and because yeah, how do we get P? I think it might be a little tricky. Because yeah, then we have to find E prime and F prime. And then we so the line AP would map to itself, right?
Actually, we shouldn't use inversion because we cannot understand where O goes to.
Yeah. I don't necessarily think it's possible because yeah, the line AP goes to itself, but E and F would be a little tricky.
Then we cannot understand angles if we inverted O.
If we invert at O. Yeah, that's what Khan was thinking. So what's the best way to show APMO is cyclic? Power of a point, angle chase, what else is there? Radical axis theorem, stuff like that. So I want to use that the circumcircles of ADB and ADC are the same size. I'm not sure exactly how to use that. Maybe we could draw the centers of those circles. So yeah, I'm going to try that. So basically, we kind of get a rhombus. And it passes through M. So center, so we draw the center of E1 and the center of C1. Oh, the center of E, center of C1. Not sure if this will work, but I'll try it out. And those all pass through I. So yeah, this is a rhombus H. I don't think that passes through F, but yeah, maybe I'll just leave it like this for now. So HM is equal to MI. So yeah, I wanted to, maybe we could show angle PAC is equal to angle PMC. Oh no, I'm sorry. PAC is equal to PMO. So PAC is equal to angle B. PMO, we can maybe break it up into PMI plus IMO. Yeah, what if I did that? PMI plus IMO. So that is still a little tricky though. Let's see if we can put this on. Can we say anything special about that circle? We find its center somehow. Yeah, how do we find angle PMO? So interesting. Let's see. Can we find another point on that circle? So that's like the other way to show cyclic quads. If we could find some other point that also lies on it. I don't know if there's any sort of special point. Let's see. I wonder if HI passes through this point. No. So what if I tried dilating? I want to use that AM is equal to MB. Yeah, what if I take APMO and I try to dilate it by a factor of 2 about A? So I kind of like that. So A would go to the antipode of A. I would go to the antipode of A in this circle. And P, we would have to reflect A over it. I'm going to try that. So we want to show it. AJD. Oh, we don't need point K. I'm sorry. We just need to reflect P. So ADJ prime, we want to show is cyclic. But yeah, what is A prime? So we have like OP. Yeah, it's a dilation. A prime C. Yeah, let's see. A prime. Yeah, is A prime C tangent? That would be very interesting. No, I think it can intersect all the circles. It's not that easy. But what would the circumcenter? So let me draw. If it was cyclic, then the circumcenter would lie on HI, right? So maybe we could show angle AKP equals angle AB. We have to use ENF somehow. That's the problem. We haven't used it. I don't know about my dilation idea. I might just erase it. Let's see. So let me erase J and K. Yeah, is there some tangent line to the circle APMO? Let's see. There's a lot of theorems on like circles passing through centers of other circles. So maybe maybe we could label this point, for example. I'm not sure if it would help. Let me draw the center of the circle. Maybe PJ. I don't think PJ and O are collinear, but it's worth a guess. Ah, looks like it. Let's see if that's a coincidence or not. Yeah, P is the antipode of O. That's pretty interesting. Oh, well, yeah, that would have to be true if the problem were true. That's because angle OAP is 90. Yeah, okay. So yeah, that's obvious. If it were cyclic, then that would be true. So basically we want to show angle OMP is 90. We know PA squared is PE times PF. Okay, so yeah, we want to show angle PMO is 90 degrees. So we don't know the circle exists, and we want to show PMO is 90 degrees. What if maybe poles and polars or something like that? Um, Yeah, what if we reflect M across the circle? So we want to show P lies on the polar of M prime. Yeah. So AP is the polar of A. EF what do you get when you take the perpendicular from O to EF? That means that so yeah, I think the reflection of J over the circle has to lie on AM prime. Yeah. For the, if the problem's true. Yeah, this is kind of interesting because M is the midpoint. Well, actually, it's tricky. Yeah, basically, if we could show J prime and M prime are collinear with A, that would solve it. We know that J, we know that this is cyclic. Yeah, we have to use the angle condition somehow. So we could use it. So the circumcircles of ABD and ACD are the same size. But yeah, I don't know how to use that. Now let me delete all these prime points. So yeah, HAID is a rhombus. I don't know how much that helps though. Maybe some medians. We could use some medians somehow. Although there's not much. Yeah, let's see. I don't know. You guys want to go back to the other problem? Let's stick with this a couple more minutes. Okay, yeah, so showing that PMO is 90, I think that's a good place to start. We know that angle DMI is 90, right? So that could be really where we use that the angles are equal because, oh, well, actually DMI would always be 90. But let's see. So we want to show DMO is PMI. Is DMO similar to PMI? I don't think so. This is hard. Ah, you got a solution. Share it.
First of all, we label X as the intersection of AB and CD.
AB, okay, so should I draw the intersection of AB and CD?
Yeah.
Okay, hold on just a second. And yeah, I can rename it whatever you want if you want.
Yeah, name it X, please.
Okay.
Now that, yeah, it's okay. Now let Y be the intersection of BD and AC.
Okay.
And extend XY to meet BC at H.
Okay. So XY.
Meets BC at H.
Okay. Let me erase these two circles actually, because I don't think these circles are part of your solution, right?
Yeah.
So hold on a sec. So that should be H. All right.
Yeah, so firstly, I claim that BXYC is cyclic.
Okay. Let's think about that. So,
Yeah,
all right.
that's
Angles are given.
BDY were collinear,
Oh, sorry.
the segment.
So yeah, that's obvious because those angles are equal. Yeah. So
Yeah.
BXYC is cyclic.
Yeah, and now I define K to be intersection of AH and the circle.
Okay. EH or DH?
AH.
All right.
Yeah, the point K.
That's K.
Now I claim that DK is perpendicular to AH.
Okay. So
Michael,
mhm.
I think I have a solution, but it kind of difficult and complicated. So yeah, I will prove that PM is perpendicular to OM.
Okay. Well, hold on one sec. Let Anmol finish his idea, and I'll type it up, and then I'll type up your solution.
Okay.
But thanks.
So I extend AD to meet BC at I.
Okay.
And to meet the circle at J.
All right.
And then I extend KM to meet the circle at G.
G.
Yeah.
All right.
Now we would prove that AMOG is cyclic and AMPG is cyclic.
Okay.
That would prove APMO cyclic.
Mm-hmm.
Yeah, so after proving DK perpendicular to AH, we would claim that MG is equal to MJ.
MG is equal to MJ.
Yeah, basically M flips the line.
Okay.
So yeah, and this would prove that AMOG is cyclic.
Okay. By an angle chase. Yeah. And then, okay, so let me write it out step by step. So yeah, first I'm gonna write out your solution, and then I'm gonna write out Feng's solution. Sorry if I mispronounced that. So, all right. So first, so here's the first solution. Let BD meet AC at Y, and let CD meet AB at X. So then angle ABD equals angle ACD. That means that XBCY is cyclic. And let AH meet the circle at K. And let KM meet the circle at G. And then you want to show that both AMOG is cyclic, and then I'll also say let AD meet BC and O at I and J. Okay, so first you show that AMOG is cyclic. So basically, I think you said that MC, did you say that MG is equal to MJ? So yeah, so OM basically bisects JMG. Let me think how you showed that.
Yeah, so I first claim that DK is perpendicular to AH because the quadrilateral BUXYC is complete. And I can apply Brocard here.
So by Ricard's theorem, yeah, it's kind of like, so K is the McKell point of that. Right. So by a well-known theorem, basically K is the McKell point of that quadrilateral. Yeah. So we have like, and DK is perpendicular to AH. So I'll just say that that's well known for now. So K is the McKell point of EXYC, and DK is perpendicular to AH. All right. And all right.
Yeah, once I know this, I can claim that M being the midpoint of AD and triangle AKD being right angled, then MA should be equal to MK.
Okay. So since angle DKA equals 90 and DM equals MA, then that means that Right, hold on one sec. So that means that MA is equal to MK. All right. And so then by an
Yeah,
angle
once I
chase,
know
we can show that,
AMOG is cyclic.
yeah, exactly. So we have, yeah, I think I could write this one. So angle AMG is equal to
I think the quickest way to reach angle AOG from here is to write AMG as KMD and then writing it as 2 KAD.
oh, yeah, I think I have a pretty fast way. So AMG, it's half of arc AG.
Yeah, that works too.
Yeah. Plus half of arc HJ.
And both the arcs are equal.
Yeah, exactly. So and that's equal to G, which is angle AOG. See if it fits on one line. Ooh, it all fit on one line. So AMOG is cyclic.
Yeah, now we claim that AEGF should be harmonic.
Okay. AMOG is cyclic. And then what was the next step? Something's harmonic.
I think he said AEGF.
AEGF is harmonic.
Yeah.
So that kind of means PG is tangent.
Yeah. After that,
Yeah,
cyclic
that would
is-
imply PG is tangent.
Okay, so how do we show AEGF is harmonic?
We start off with the cross ratio CBIH
Okay,
and take it from the line to the circle through A and then through M.
take it to the circle through A, so that would be KBJC, and then the circle through M.
And flip it through M, that would reach AEFG.
Okay. All right, let me just think about this. So KBJC, so can we do that? So we can project through a point that's not on the circle like that?
Yeah, I asked the same thing on IOPS some user, and that's okay to do.
Ah, okay. Interesting.
Yeah, you can technically visualize this as making two lines AC and KJ, taking from circle to line to line, and then back from line to circle. Technically the same thing as taking points on circle to points on circle.
Okay, so KBJC Yeah, I thought I'd tried that before and like there were issues with it, but I guess it works. So you can project through a point that's not on the circle, right? Okay. Well, then then that's really nice. So let me make some room here.
Yeah, the motivation behind this was knowing the condition that I can express this angle condition in terms of BXYC.
Right. In terms of
And
BXYC.
once I expressing in BXYC then makes it a half in complete quadrilateral, which motivated me to make the point K, and from there I
Wow.
actually got a hint from GeoGebra that G would be the point of tangency from P.
That's pretty awesome. So what did I name the other point? K. And then which is equal to DC projecting through M. It's E F A G. Okay, so that means that EFAG is harmonic. And once we have that, that means that PG is tangent to the circle. Let's see. Oh yeah, this is an awesome solution. Yeah. So absolutely, this is like a really cool solution. So then we know that PA is equal, or PG is tangent to the circle. And then I would guess it's probably an angle chase. So because OPAG is obviously cyclic. So yeah. So OAP is OGP is 90, implies OMAPG is cyclic. Or I'll say APGOM is cyclic. All right, so that is the first solution. So thanks, Anmol. And
I think that my solution is much more complicated than this. So yeah, I think it is difficult to show you. My idea is that using Pascal and Menelaus.
okay.
Yeah.
Yeah, you could put it on the Discord chat too. So yeah, it's kind of hard to do here. Yeah, I'd be really interested in seeing it on Discord.
Yeah. Okay.
But yeah, definitely. So now we'll go back to that one problem that we still had remaining. So yeah, we have about a half hour left. Hold on 1 second. Oh wait, do I have one more problem? Oh, I never did this one. Yeah, so this is not the problem that we didn't solve yet. This is a different one. But it's also kind of interesting. Sorry, let me check the chat for a sec. Oh, so yeah, Anmal just said that he learned about the problem in his regional train or some angle condition in his training, which is pretty interesting. So we have the in-center, orthocenter, and circumcenter, this triangle. And we draw the feet of the three angle bisectors. So this problem's from 2018. Okay, so we have DEF, and we draw the orthocenter of DEF. So this looks a lot like the Sharky Devil a little bit, because we have the yeah. So an H X is and then that point should be I in the center. Whoops, sorry. Let me draw a point I, then I see someone said something in the chat. We want to show that IX is parallel to OH. Similarity, yeah. It feels like some kind of a homothety. So maybe I'll just draw the midpoints of those three arcs just for the heck of it. 1, 2, 3. So yeah, OH is the Euler line. So it also passes through the 9-point center. So is I, what is I for this? I is this, I don't think it's the circumcenter, no. I is just like a random point in triangle DEF, right? So OH, that's like a whole line that passes through a bunch of sort of well-known points. So yeah, if they're parallel, maybe inversion works. I don't know.
Are these 4 points form
What?
trapezoid? Maybe they form an isosceles trapezoid.
Oh.
Okay,
think-
they're not.
Yeah, I don't think so. So yeah, X, so yeah, O and H, the midpoint of OH is the 9-point center. Yeah, it's weird, the orthocenter of triangle DEF. I'm not sure what to say about that. Very centric. Yeah, yeah, just for the theme of this channel, I try to avoid it, but nothing wrong with using it in competitions. So yeah, I know EGMO has a chapter on it. Very centrics and complex numbers. Let's see. So do you guys want to stick with this problem or go back to the other problem that we were doing? This one looks kind of hard. Yeah, let's go back. All right. Was it this one? Forgot which one it is. Let's see. It's taking a little while to load, sorry. Should be this one. Give it a few seconds. My computer's a little slower here. There we go. All right. So I'm waiting for it to maximize. But yeah, I think we were very close with this. But at least that's what it felt like. Sorry about that. Let's see, there we go. It's so slow, sorry. All right. My computer is not reacting too well. There we go. All right. So we define Q prime to be the intersection of the tangent at C with that line. And we showed that line exists by Pascal's. Did we show XG is parallel to BP? I'm not even sure. But then we wanted to show XD and Q prime are collinear. And I think that would solve the problem. Let's see. BAXE is equal to PF Q prime E. Yeah. So what if we projected through M? So BAXE is equal to B this point DC. I think that would be very close, right? So let me draw that point right there. And then PFQ prime E, we could try projecting, I guess C is the most logical point, right? Or project through C onto the circle. But where would F go to? That's the only thing. Maybe, yeah. I don't know right now where F would go to, but maybe we could figure it out. Yeah, okay. So I'll draw that, and I will draw the intersection point. So I'll call I. So PFQ prime E is the same as B I C BICM. We want to show BICM as BHDC. Which is I. How do we know BICM is? Is it hard? Oh, because it's. Sorry. But wait, so I wonder, is ID perpendicular? Like, to no. What if? Right, that doesn't seem, something seems weird with that. But let me first write out what we've done so far. So yeah, I don't think BIC, like, I think that's what we want to prove, yeah. Let me write out what we've proven so far, just because we have 10 minutes left. So, so first we use Pascal to show that PF and E are collinear, right? So by Pascal's on ABB MCC, P, F, and E are collinear. Let the tangent at C meet this line at Q prime. All right. So oh no, yeah, I'm just writing what we got so far. So yeah, so show me first how we got to the, so let Q prime C meet AP at G, and then I think you use Pascal's again, right? So somehow you use Pascal's to show D, G, and E are collinear, right? Oh, by Pascal on CCMAAB. Then, so yeah, CCMAAB, we have E, G, and D are collinear. Let me check that. So wait, so how did we get that? So wait, CCM, is that right? Pascal's theorem and this shows that E, G, and D are collinear? Because yeah, CM meets AB at E, CB meets AM at D. Oh yeah, and the two tangents at A and C. Yeah, okay. So that makes sense. And then we try to project through so yeah, if we could show X, D prime, and Q are collinear. Well, why did we need to show that E, G, and D were collinear? A, B. Yeah, did we need point G? So we have XG is, we want to show XG is parallel to BP. Kind of looks like it. Yeah, I'll just start writing out some stuff. So, so we want to show that BXAE. Okay, so let me go back. We wanted to show that BAXE so BAXE, I projected it through H, right? No, through M. Projecting through M. is equal to BAH or BDHC. And that we could project BDHC through I, right? So actually, maybe we should just project through I. Actually, never mind. PF. And then PFQ prime E, we could project through G, I think was the idea. No, projecting through C. That would be BCI BICM. Sorry. And what if we take those points and we project it through B onto AF? So that would be F, M, yeah. Yeah, it seems like we're very close. Let me just think about it a little bit more. BICM. What if we projected them through C onto BF? So BICM. So basically that means, you know what that means? Because BDHC, we could project through A and we would get BMC in this point. All right, we're out of time, so I think I'm going to end it here, but it feels like we are really close to solving that one. It can work if we project onto BF. Okay, but it takes a little more calculation. All right, I'll leave that. I'll leave the rest of it for the viewers. But Hakan says we have a solution if we project onto BF. All right, so thanks everyone for participating. We're getting a larger and larger group here. And yeah, this is a lot of fun. So sorry, my internet was a little slow, but see you all next time. Have a good one.